Hello everyone. So I just want to put together a little supplementary video on practicing some more radian angle measure drawings. So this is a really fundamental skill in my view for building a good visualization system for understanding the unit circle. So as a result, it's really important to get down this ability to draw these angles. That way you'll be able to picture them easier later on. So with that being said, what we're going to do is go through here and do quite a few additional examples of drawing radian measure angles. So first thing we got to talk about is pi. So whenever we're talking about radian measure angles, remember this is about the ratio of the length of the arc of a circle to the radius of the circle. And that ends up working out, as we saw in our video on angles and their measure, to telling us that the straight angle, so the straight line, so if you take this is your initial side and you rotate it here, right, that angle is pi. So everything we do with drawing radian measure angles usually comes back to just thinking about portions of pi. So what I'm going to do is first look at my X and Y axis here and mark the X axis with a highlighter, just to indicate that that's pi, so that's what I have to think about kind of dividing up, right? So here I'm looking at pi over 6. So the way I'm going to draw this is 1/6 of pi. I'm going to look at the straight line that I've highlighted here and say, okay, let's divide that into 6 pieces. 1, 2, 3, 4, 5, and 6, right? So there's 1 segment, 2 segments, 3 segments, 4, 5, 6 segments. And then we'll draw our actual angle in blue. So this is our initial side here. And then since this is 1 pi over 6, I'm going to rotate through 1 of those pi over 6 segments. So that's pi over 6. Now here we've got 3 pi over 5. Now dividing pi into fifths is a little bit harder to do, but you don't have to worry about getting these pictures perfect. You just have to worry about being able to relatively correctly position the segments. So here what I want to do is say, okay, I want to take this straight line and divide it into 5 segments, right? 5 angle segments. So, you know, something like 1, 2, so this is 1 segment, 2 segments, 3 segments, 4, and 5. And so when I go to draw my actual angle, here's my initial side on the positive x-axis, as always. Whenever we're drawing a standard angle, all right, we start on the positive x-axis, and we need to rotate through 3 of those fifths, right? We divide it into 5 pieces, and we want 3 of the fifths of pi. So I go 1, 2, 3. So now this is my terminal side. And what I've drawn in blue is the angle 3 pi over 5. Okay, so let's do one more of these simpler examples like this. Pi over 2. Okay, so that's easy enough. Here's my straight line. How do I divide that into 2 pieces? Oh, well, I'll just mark right here, straight up and down. Again, when we think of dividing this up, you know, I've drawn an X and a Y axis here. So I just want to emphasize that the X and Y axis, the X axis matters because we're starting on the positive X axis, but you kind of ignore the Y axis. You're just taking the straight line pi and dividing it up into the appropriate number of pieces. So here, when I look at pi over 2, I'm just dividing this straight line angle into 2 possible pieces. And so when I draw my angle pi over 2, that's 1 pi over 2. So this is my initial side. This is my terminal side. And this angle is pi over 2. Which, of course, is the right angle. All right, so now let's take a look at negative angles. So remember, we draw all of our angles from the positive x-axis counterclockwise when they're positive. That's our convention. So when we're talking about negative angles, we're going to draw clockwise. So negative pi over 4, again, I'm going to just highlight the x-axis because that straight line is the angle pi. And I just have to remember that I'm going to be rotating from here downward, clockwise. So I need to divide this up into 4 pieces. So this looks about like this. So now I've got 4 congruent angles, and I want to go clockwise 1/4. The negative tells me to go clockwise, and this is 1/4 in that direction. So I go rotate out one of those 4 pieces, and that's my angle, -pi/4. Okay, so another negative angle, -2π3. Okay, so same idea. We're starting, all right, we're looking at our angle pi, and we want to divide it up into thirds. And since we're starting from the positive x-axis and going clockwise because the angle is negative, my thirds are going to look roughly like this. All right, just take that yellow line, divide it into 3 roughly equal pieces, and now we're going to rotate clockwise through 2 of them. All right, that's 2/3 of pi. So this is -2π3. All right, now negative pi. This is a real easy one. Our straight angle is pi, right? So if I'm going pi but in the negative direction, I can just rotate and complete the straight line. As long as I'm rotating clockwise, that's -pi. Okay, so now we'll deal with slightly more complicated angles. So these are angles bigger than pi. And so now we have to think about, okay, how can we rewrite this in a way that makes it easy to determine how to draw it? So when I think of 5π/4, what I'm going to think of is, what's the largest number divisible by 4, but that's less than or equal to 5? Well, that's 4, of course. So I can write this as 4π/4 plus π/4. And 4π/4 is just pi. So the whole goal here is to rewrite this as multiples of pi here plus some smaller portion of pi. All right, so let's see how that helps us draw 5π/4. So what I'm going to do is start by drawing my multiples of pi. I've got a pi here, so I go out pi, and I'm going to put a little mark on my graph every time I rotate pi, just because it's going to help me keep track of what I'm drawing. So I rotated out pi, and now I have 1/4 of pi left. So I rotated 1 pi out, and I'm going to divide the next pi into 4 pieces. And then I'm going to rotate one of those 4 pieces of pi. And that's 5π/4. So now let's do 5π3. And we're going to think about this in the same way. I'm going to rewrite 5π3 as 3π3 plus 2π3. Again, I just started by saying, what's the biggest number, less than or equal to 5, that's divisible by 3? And of course, that's 3. And 3 divided by 3 is 1, so this is pi plus 2π3. So let's draw that straight highlighted angle again. And I'm going to do the same thing. I start with my initial side here. I'm going to rotate out pi, and when I get to pi, I'm going to mark just a little dot to keep track. I've gone 1 pi. And now I need 2/3 of pi. So I've gone out 1 pi, and now I'll divide the next pi into 2/3, or into thirds, I should say. And I need to rotate 2 of those thirds. 1, 2. So this whole angle is 5π3. And now 3π2. All right. So I'm going to go a little faster here. 3π2 is 2π/2 plus pi/2. That's pi plus half of pi. So I start, I draw, I rotate through pi. Now I need half of pi. So I rotate another half of pi. And that makes this my terminal side. And so this angle is 3 pi over 2. Okay, so we've done all of the like sort of basic common stuff, small angles that are positive, small angles that are negative, some slightly bigger angles, angles that are just a little bit bigger than pi, but less than 2 pi. So now let's deal with some more challenging examples. Here, we've got 22 pi over 3. So the first thing I'm going to do is think, what's the biggest number less than or equal to 22 that's divisible by 3? And that's 21. So I'm going to write this as 21/3 of pi plus, and then if I've got 22 total, I should have 1/3 of pi left. In other words, this is 7 pi plus pi over 3. So again, pi, that's our straight angle. So let's start on the positive x-axis as always. And now I need to go 7 pi this time. So every time I rotate a half circle, every time I rotate through that straight line, I'm going to mark it. That's 1, 2, 3, 4, 5, 6, 7. So now I've gone 7 pi, and I need to go another third of pi. So now I'm going to look at the next pi and divide it into thirds. And I'm just going to draw that little extra third there. And so this will be my terminal angle, or terminal side for my angle. So altogether, this angle is 22 pi over 3. So the whole goal here with taking this approach to drawing these angles is that we're taking this seemingly complicated angle, this large angle, and we're turning it into two simple angles. A straight multiple of pi, and then a angle that's less than pi, so that it's just a little bit easier to handle and visualize. Okay, so now 17 pi over 4. Okay, so I'm going to write that as 16 pi over 4 plus pi over 4. In other words, 4 pi plus pi over 4. So here's our straight angle. This is my initial side. And we go 1 pi, 2 pi, 3 pi, 4 pi. And then we divide this into 4 pieces. All right, so now we've got 1, 2, 3, 4 chunks. And we go through 1 additional fourth of pi. That's our terminal side. And so altogether that angle is 17 pi over 4. And lastly, we'll do one of these pretty large angles, but negative. So the process doesn't change much here. You can just think of this the same way you thought of these, splitting up the angle into 2 negative angles, right? And we're still thinking about multiples of pi. So the largest number divisible by 2, that's less than or equal to 9. Well, that would be 8. So I'm going to make this negative 8 pi over 2 minus another pi over 2. Altogether, that's negative 9 pi over 2. So we can rewrite this as negative 4 pi minus pi over 2. And then we do the same process, but now we go clockwise. So I start here, and I go minus pi, minus 2 pi, minus 3 pi, minus 4 pi. So I've done the 4 pi, the negative 4 pi, and now the next negative angle, I'm going to divide into 2 and go another half of pi in the negative direction. And so altogether, that is my negative 9 pi over 2 angle. Okay, so that's all the examples that I have for drawing radian angles. Hopefully that covered things pretty thoroughly, kind of covered every situation you would expect to come up, I think. So yeah, hopefully that was helpful. Thank you for watching.